So now that we've learned the basics of logic, we can finally start discussing proofs. And as I discussed in the very first introductory video and motivation for this entire course, proofs are going to allow us to do multiple different things. For example, verify that an algorithm is correct, design efficient data structures and algorithms, as well as proofs could allow us to show that no algorithm could possibly solve some sort of problem. And so I don't want you to be motivated by proofs, because indeed all that a proof is basically a series of logical steps or instructions to produce or verify something. And you might be thinking to yourself, well, that actually sounds a whole lot like just programming in and of itself. And indeed, there is a very close analogy between writing code and actually writing proofs. So for example, you might write some pseudocode that looks like the following. So you could write a program that looks like this very simple thing right here. While some sort of condition is true, and then we have this if statement in here. If you have some sort of condition, you do some bunch of instructions over here. Otherwise, you do alternate instructions, and then you end. So we have a very simple program right here, written in pseudocode, that's simply a series of logical steps or instructions meant to produce something or verify something. Proofs are very similar. So a proof could look something like this. So proof in quotes right here, because typically we don't actually write proofs in this indented sort of pseudocode kind of format right here. But you might see some similarities between these pseudocode right here, as well as this proof here in quotes. We are letting X be arbitrary, and we have some sort of logical statement right here if it's true, and then we have to fill in the blanks and give a proof of Q of X, and then we have established that P of X implies Q of X. If not, we've established that for not all X, P of X implies Q of X. And if we go through all this and letting X be arbitrary, then we are able to establish that for all X, P of X implies Q of X right here. So what we're going to do in this entire section, in this entire unit, is first off, discuss how to construct arguments. So basically, we want to go from this sort of format right here and convert it into some sort of paragraph form. So a paragraph form that uses English language, logical symbols, math symbols, etc. So we're going to first off have to figure out what valid arguments are, what valid proofs are right here, as well as construct a toolkit to be able to make different proofs. So similarly to when you're writing code over here, you have an extensive toolkit of instructions that you might use to write your program to produce or verify something. We want to build a toolkit of different proof techniques that we can fill in this spot right here that helps us prove Q of X in this particular case right here. So we're going to discuss arguments and then discuss a toolkit of different proof techniques.